In this 4.4, we're going to look at, indefinite integrals and then the net chain theorems. So from the previous sessions, right, fundamental theorem of calculus, we know that the relation between, antiderivatives and integrals, they are the same, right? That's how we can connect it from fundamental theorem of calculus part 1. So in the definite integral, what's going to happen is this. Take a look at it. The integral doesn't have what? Lower limit and upper limit anymore. We are talking about in the general, right? So integral from integral of f of x dx, right, without lower limit and upper limit, that is called the indefinite integrals. That's basically talking about the antiderivative of this lowercase f function, right? And you will get this antiderivative functions in a family of them. So when you do indefinite integrals, you need to make sure you add a constant at the end. So notice that all of this are basically very similar to the antiderivatives formula that we have from the past, right? This first of few are basically from properties of integrals, right? First and second. And this 3, 4, 5, 3 to 10, that's basically the antiderivative formula that we had from the past. Right? So these are what we're going to be using, right, to evaluate for these sections. So now we extend it to sine, cosine. Okay? So for example A, if we are integrating from x, the function x minus 12 sine x and then dx, right? And the way that we can look at is, right, using the property number 2, I can say that integral of x dx minus integral from integral of 12 of sine x dx. Then I'm going to be using, right, number, this is basically a polynomial right here. So when you take the integral, it's basically antiderivative of x. That will become at 1 and then divided by 2 minus, for this one, I can look at as 12 times integral of sine x dx, right? Which is basically using the property number 1. So I'm just writing down step by step, right? Eventually, like next example, you will see that all of this process we're going to be doing man to man. So this will give me 1/2 x squared minus 12 times antiderivative of sine, right? So that's basically what you see, that it's negative cosine. So it'll be giving me negative cosine x. And since this is indefinite integral, we will get a family of functions, antiderivative functions. So you need to add constant at the end. So this will become 1/2 x squared plus 12 cosine x plus a constant. Any questions before I move any further from here? So for this one, basically, what we need to do is we don't have a formula to take antiderivative of this. So what we're going to do is we're going to simplify it first, right? So you can look at this one as x over, right, x to the 2/3 power minus 1 over x to the 2/3 power when I split it into two different fractions. So when you simplify this portion right here, on a numerator has 1, right? So this will become x to the 1/3 power on the first term minus x to the negative 2/3 power and dx. So now I can basically take the antiderivative of this functions, which is the integral. So if I take the integral of this functions, that will become x to the 1/3. I add 1 and then divide by that value. And then plus or minus x to the negative 2/3. I add 1 and divide by that number. And make sure that you add a constant because that will be a family of function. So finally, when I simplify this, this will become 4/3. When you reciprocate it, that will become 3/4. And x to the full third power minus, and when I combine the denominator, that will become 1/3, which is going to be reciprocating. It will be kind of 3 and x to the 1/3 power plus a constant. And this will be my integral, right, of this functions, which will give you what? A general, right? A family of functions right here. So any questions? So again, I have, my antiderivative formulas are very simple ones that we have so far. So you need to somehow manipulate it to get into this, the formula that we can use. So for this one, I can basically rewrite, this into 2 sine t cosine t using the identity that will allow me to reduce sine t. So that will give me integral, and I'm going to bring this 2 out. So it'll be 2 integral of cosine t dt. So now when I take the integral of cosine, that's basically what? Sine t, and don't forget to add a constant plus c. So that's the trick that we're going to use on trigonometry function. How do we, integrate this function? So we want to basically same situation again, try to simplify it to a situation that we know how to continue. So first thing that I see is I can factor the numerator out. So that will be sine theta 1 plus tangent squared theta secant squared theta d theta. And we know that 1 plus tangent squared theta, that is equal to what? Secant squared theta. Okay, you need to remember our identity. So this will give me secant squared theta. So that will allow us to simplify, and that will give me integral of sine theta d theta that we want to take. So integral of sine, that's basically negative cosine theta plus a constant. And that will stop right here. You can basically take the derivative to c, right? Because these are inverse operator of each other, integrals and then differentiations. So the derivative of cosine is what? Negative sine. And with this negative, that will become positive sine. That's what we have. A constant, derivative of constant is 0. So that's the function that we got back. So it's very consistent, right, from the theorem that we have. So you can see that, if v prime of t, that is the rate which the water flows into the pool at a times t, right? So going back to the rate of change, right? When you're talking about the integral from t sub 1 to t sub 2, which is the starting times to the end times of this rate of change functions, right? So how fast this is growing, right? Going into the pool. That basically going to tells you what is the change in the volume, because you can take a look at this right here. At time t, your water is right here, t sub 1. Right, so that's the volume at time t. And at times t sub 2, that's the volume of the water into pool at that time. So if you subtract these two, right, that's basically tells you, right, what is the net change in the volume. But this idea is basically the same thing as what? You are taking integral from t sub 1 to t sub 2 of the rate that the water is pulling in to the pool. So that's basically the, the net chain theorems. That's what we're talking about right here. So, it's useful because the next one that you're going to look at is what? The rate of change in the product, right? So if C is a cost of a product at X units, right, of goods, then we know that C prime of X is basically the marginal cost, which is what? What is the cost? What is the rate of change on the cost for producing the next one more item, right? So if you are taking integral of this marginal cost, that will tells you, right, what is the increase or decrease in the cost of the productions from, producing one more item or X amount more items. Okay. So this is the net chain area problem, right? Net chain theorems. So what we want to do is we want to look at the same old example which we did it separate parts, but now we can do it in like one shot. Okay. So here's the example. So giving you a particle is moving along, and then the velocity of that particle is giving you with the function t squared minus t minus 6. And the velocity is basically the rate of change, right, of the position function. So if you want to talk about the displacement, okay, if you want to talk about the displacement from the beginning to the end, right, during the period of 1 to 4, is basically what you're taking this right here. Derivative of integral of velocity function, which is another way of saying it is integral of the rate of change of the position function. Right? So the displacement, right, part A, to find out the displacements, that is basically integral from (1 through 4) of this function t squared minus t minus 6 dt. So when I take the integral of this, notice that right now we can do a lot faster, right? So this will become what? The integral of this will be t to the third divided by 3 minus t squared divided by 2 minus 6t, and we are evaluating from 1 to 4. Right? So when I evaluate this, that will basically become 4 to the third power over 3 minus 4 to the second power over 2 minus 6 times 4 minus, evaluating at the lower bounds, 1 to the third power over 3 minus 1 to the second power over 2 minus 6 times 1. So what do we get? See, notice that right here, this portion right here and this portion right here, that is basically you're finding the difference on the positions at those two different times. So that because that's how we're going to be getting the displacement, right? So this will become 64 over 3 minus 16 over 2, which is going to be 8, minus 24, and negative 1/3 plus 1/2 plus 6. So this will give me 64 over 3 minus 1/3, that will be 63, which is 21, right? Minus 8 minus 24 plus half plus 6. So now this is basically become negative 3, negative 11, negative 5 half, so negative 4.5. So that's my displacements right here. Any questions before I move any further? So when you're talking about finding out the total distance travel, right, not the displacement anymore, the total distance travel between these two, right, interval from 1 to 4, time 1 to 4, then The formula is basically you are taking the absolute value, okay, absolute value of the rate of change in the position function, which is a velocity function. Right? So in this case, what we are looking at is we are looking at the distance traveled and particularly total distance. That will be from integral from 1 through 4 of absolute value of t squared minus t minus 6 dt. Now, this is where it's going to become like, very tedious work that you need to do in this case, okay? Because I need to make sure that, because we don't know how to take integral of absolute value. So we need to somehow get rid of this integral absolute value form. So what we need to do is we need to find out, right, what is happening on this t squared minus, t squared minus t minus 6. So we take a look at this, t squared minus t minus 6. Okay. When is this going to be a positive value and when is this going to be a negative value? That's what we want to find out. Okay. So finding that part out is simply, you can take a look at it this way. When I factor it, it'll be t minus 3 and then t plus 2. Right? So this is my v of t functions. Okay, everyone. So that tells me t is going to be 0, right, at 3 and then negative 2. So do we have those interval in there or not? So take a look at on this right here. Negative 2 and then 3 right here. Okay. So I want to look at this interval. What is the value of t is going to be? What is this value is going to be? So when I plug it in 0, that will be negative. When I plug it in 4, that will be positive and positive, so it will be positive. Okay. And when I plug it in negative 3, that will be negative and that will be negative, so that will be a positive also. So I know that this function will be one would that be a positive value and one would that be a negative value now. But what we are only interested in is the interval from 1 through 4. So from 1 through 4, okay, then we know that from 1 to 3, this function is a negative value, and 3 to 4, this function is a positive value. So now I can basically write this now, okay? Absolute value of v of t, that's equivalently saying, right, without absolute value, equivalently saying, it will be just v of t, right, on between 3 and 4, right? When t is between 3 and 4, because this is going to be a positive function. But however, we need to make negative v of t when it is between 1 and 3. Okay, between 1 and 3, because our limit is from 1 through 4. So that's why we are interested in 1 through 4 right here. So this is the important part that you need to be able to see so that I can rewrite this integral into this. Remember the properties of integral. I can have integral from 1 to 4. I can break it down into 1 to 3 plus with integral from 1 through 3 to 4. That's basically talking about all the integrals. So now we need to go accordingly because I have to put the definitions of this absolute value. So from 3 to 4 is the original function v of t. So I have no problem just writing down t squared minus t minus 6 dt. But however, on the interval of 1 to 3, that will be negative of v of t. So it will be negative of t squared minus t minus 6, okay, dt. So now I have to evaluate these two to get my final answer. So I can bring this negative outside. So that will be negative, right? Integrating this portion, that will be t to the third power over 3 minus t to the second power over 2 minus 6t. And then evaluating from 1 to 3. And I'm going to add it with integral of the second part, t to the third power over 3 minus t squared over 2 minus 6t, evaluating it from 3 to 4. Now let's try to evaluate that. So when I substitute, lower limit and upper limit for each antiderivative function part, this is what I got. Now let's use the calculator to evaluate this and then see what do we get. Make sure you give me in fractions.